Everybody, this is your video on multiplying and dividing rational expressions. In this video, I'm going to show you how to do algebra work with rational functions. So far what we've done with rational functions is we've graphed them and we've focused mainly on asymptotes and intercepts. Now we're not going to be graphing them at all. The main thing we'll focus on is the algebra behind the scenes. So our main goal will be multiply, divide. We'll also be adding and subtracting. That will come next. Multiplying and dividing is much easier and simpler. So the next 2 days will be a little bit quicker. The adding and subtracting is a little bit more involved. So our goal here is to always get our rational functions in simplified form here. Simplified form, remember, is when the numerator and denominator will have no common factors at all. So that means if you have in a general form, a times c over b times c, anything that's common you would cancel out, leaving you with a over b. This is an example of simplified form. So anything common you have to cancel. Now, what it'll look like when you actually do it with rational expressions is, let's say you have these factors. If you end up with something like this would not be considered simplified form because there's canceling that you could be doing. After you cancel the expression you're left with, that would be considered simplified form. Now we are going to focus on when you're allowed to cancel and when you're not allowed to cancel. If our factors are connected with multiplication, you are allowed to cancel. So make a note for yourself here. Canceling only works when factors are multiplied. Because very soon we will be adding and subtracting, and it's very tempting to cancel there as well, but it doesn't work when your factors are added or subtracted. So what we're going to do here is they won't be given to you like this. You will have to get them in that form. So to simplify a rational expression, what we're going to do is factor the numerator and denominator. And what you'll do next is cancel / divide out common factors. So let me show you a quick example of what that would look like, and then we'll get to, just like always, we'll start with simpler ones and move to more and more complicated ones. So let's say I have something like this, x squared minus 2x minus 15 over x squared minus 9. This lesson is going to be a really good review of all your factoring skills because they're all going to come into play here. So to simplify something, what we're going to do first is factor the numerator and factor the denominator. So two numbers that multiply to negative 15 and add to negative 2, negative 5 and 3. Our denominator is a difference of two squares. Things I can cancel, x minus 3. Now keep in mind, if you were to graph this, we're not going to graph it, but if you were to graph it, there would be a hole at x equals negative 3 because x plus 3 canceled. But again, we're not focusing on graphing anymore now. All right, that would be simplified form. So let's get to slightly more involved ones, because remember, our goal is to actually multiply two rational functions. Whenever we multiply two rational functions, what we're going to do is, just like you do with fractions, you have to multiply across first. That means you're going to multiply your two numerators, and you're going to multiply your two denominators, and then you would simplify as always, meaning you would factor and then cancel. So if I have two rational functions, a over b and c over d, you would just do a times c over b times d. Nothing, if anything cancels, you would cancel and then you would be done. So let's take a look at what that would actually look like here. Whenever you write these down, sometimes it's going to be a lot to write depending on how involved your rational functions are, but they'll cancel out nicely. So let's say we have this rational function right here, and then we're going to multiply it by this rational function right here. So what we're always going to do is think this is your numerator right here, and this is your denominator right here for both of them. Let's start by factoring here. You can't cancel until you factor. So I'm just going to take them one by one, and if I'm going to factor that, that would be a greatest common factor. Let's try and take out a 5x. That would leave 4 minus x, and then in my other numerator, x minus 1 and x plus 4. Okay, that is all one numerator now because this when you multiply, your entire numerator goes together. So right here, this is another GCF, and then this is a difference of 2 squares. So I can put all those factors together because now I just have one fraction here. Now, you always want to be on the lookout for canceling. So clearly you can cancel out an x minus 1. And let's see, oh, there's an x minus 4 you can cancel. 4 minus x and x minus 4. So this is really important here. These two are really, really close, and in fact, they're almost the exact same thing. The only thing different about them is a negative sign. So I'm going to rewrite this here. I'm going to do 5x, 4 minus x. I'm not writing anything else that I already factored out. Let's take this right here, and let's rewrite it. So the only thing that's different about this one and this one is that the sign is the exact opposite. So what if I factor out a negative 1 from here? Factor a negative 1 out. This would be then written as negative x plus 4, which is the same as 4 minus x, which is the same as this. So I'm going to take this here and write it there. So I'm going to put the negative out front here and put 4 minus x. Now I can cancel these two. And now I just have, oh, look, those x's cancel also. Holy moly, it's just negative 5. So that one cancels out a lot. They won't all cancel that much, but in this case, whenever you manipulate the 4 minus x and x minus 4, it cancels out real nicely. And x can always cancel out together because they're the exact same thing. For example, I'm going to take this rational function here, and I'm going to multiply it by this rational function here. So let's start like we always do, and I'm going to go ahead and write it as one huge numerator and one huge denominator and factor as I go. So let's start with this here. That would be a GCF. Looks like I can take out a 3x, leaving me with 1 minus x. This here is a trinomial. So multiplying to negative 20 and adding a positive 1, 5 and negative 4. All right, in the denominator, I have another trinomial, multiplying to negative 5 and adding to 4. And then just a 3x, can't really do much with that. So we're on the lookout for canceling. Okay, 3x is clearly going to cancel all the way. X plus 5, that's perfect. Oh, look at this. We have this again, 1 minus x, x minus 1. So let's do that same trick we did before. I'm going to clean this up a little bit just so I don't have so much to look at. Let's take the only factor left in the bottom, and let's take a negative out, making this a negative x and making this a positive 1. So 1 minus x and negative x plus 1 are the exact same thing. The signs are the same, it's just the order is different, so those can cancel. This is an x minus 4 divided by negative 1, which is really just negative quantity x minus 4, which you could also say is negative x plus 4. Any of these are okay. These two are better, though. Don't write it as a fraction if you don't have to. Examples of each. Here are 3 u-tries for you. I know you've been missing the u-tries in the videos. They are back in action. A couple hints here to make sure that this goes successfully for you. This one is like the examples I just did here. So you're multiplying 2, so factor them all in one numerator and one denominator. Cancel, simplify. This one here, you're not doing any multiplying. You're just factoring the numerator, factoring the denominator, canceling if you can. Now, remember, we haven't done this kind of factoring specifically recently. This is like the guess and check, or you can do slide and divide, or you can do grouping, either one. This one right here, whenever you factor it, you have to do grouping because there's 4 terms. So if you forget how to group, which you should remember, but if you forget, look in your notes. That's whenever you take out like the greatest common in the first and the greatest common factor in the second, and these two need to be the same. Okay, do those, and then I'll show you how to divide. Before I go to dividing, let me just remind you again, make sure you did these 3 u-try problems. Whenever we divide rational expressions, just remember, it's the same exact thing as dividing fractions, which you've been doing since elementary school. If you have 2 fractions and you're going to divide them, you have to remember the rule, multiply by the reciprocal of the denominator. And you might be thinking, well, this doesn't really have a whole denominator fraction, but if you do this divided by that, you would multiply by the reciprocal of that. So that's something you've already seen before. And this would be, then you just multiply straight across. So 10 over 72. We're going to do the same exact thing whenever we do rational expressions with factors. Same rule. Okay, so make sure you have that written down. Here's the formal rule that you would see in your book. If I have this fraction divided by this fraction, I multiply by the reciprocal of the second one, and here's my final product. And if there were any canceling to do, you would do it and get it in simplified form. So let's do an example here. I have two rational functions. I have this one divided by this one. Now, do not start factoring until you flip the one that would be in the denominator. So all you have to do is just turn it into a multiplication problem. I'm doing the reciprocal of the second one, and then it's the exact same thing that I was doing in the first half of the video. So I'm going to factor the first, and x minus 2 is just going to stay the same here. So to factor x squared minus 4x minus 21, let's see, that would be -7 and +3. And then 5x plus 15, let's take out a greatest common factor. It's the same thing that we were doing before, so we're going to look for anything that's common. The x plus 3's are common, and the x minus 2's are common. So the stuff that's left over, this is in my numerator, this is in my denominator, and nothing else can be canceled. So there you go, that's your final one. All right, let's do one more together, and then we'll call it a day. So for this one, this is one that people look at sometimes and get confused on what to do. So let's try one like that. Sometimes they'll give you a problem that looks like this, divided by just something that doesn't look like a fraction. And then people are confused because they don't really know what to do the reciprocal of, or it doesn't look like you can do a reciprocal. Just remember that you can make anything a fraction just by putting it over 1. So I'm going to rewrite this. And again, I need to turn my division into multiplication. And all I'm going to do is flip that. So 1 over 3x squared minus 2x. Okay, so let's start seeing what can cancel. So this all is going to be my numerator. This all is going to be my denominator. So we are going to guess and check this. So I have 3x squared. So the only options are 3x and x. These numbers need to multiply to -10. So let's try -2 and +5. That's 15 minus 2. That works. And then I have 6x squared. I can't really do much with that. You could write it as 6xx if you wanted. You don't have to. And then the other thing that goes in the denominator is the 3x squared minus 2x. But we need to factor that. So there's that. This is a GCF. I can take an x out, and I'm left with 3x minus 2. Okay, let's look for canceling. I have 3x minus 2. I have 3x minus 2. Nothing else is going to cancel here, and whenever you rewrite it, it would be a good idea to turn x times x times x into x cubed, just so it's condensed and simplified at the same time. So when I see you in class next, we'll be practicing this, and then you'll have homework that night, all on problems like this before we move to adding and subtracting. Make sure you do your U-tries, and I'll see you soon. Bye.